Hi, welcome you all. Today we are going to discuss about engineering chemistry. It belongs to first year BE, electrical instrumentation engineering students. And the topic today is sensor. Previous video I have discussed about three types of sensor: potentiometric sensor, amperometric sensor, conductometric sensor. The potentiometric sensor involve the use of ion selective electrodes. Their construction, working, application, and the classification of this glass electrode, everything have been discussed in the previous video. Now I am going to discuss about ion selective field effect transistor. It is one of the recent development of ion selective electrode. An enzyme linked with field effect transistor is called as enzyme linked field effect transistor, which can be abbreviated as ENFET. Here enzyme is coated with a FET, that is a field effect transistor. The detection of an analyte in the test sample gives a signal. The electrical signal is observed, recognized, and it is converted into a proper output. These are all happening in an electronic devices. Now we will see about the construction and working of ion selective field effect transistor, which is abbreviated as ISFET. The schematic representation of ion selective field effect transistor is shown here. Now we will discuss about the construction. The active area dimension is 500 millimeter long and wide 50 millimeter, thickness 300 millimeter. It consists of one p-type silicon area and two n-types of silicon chip. In this, one n-type acts as a electron source, other n-type act as a positive drain. They are insulated with 0.1 millimeter thickness of SiO2, silicon dioxide. This constitutes gate of FET. Above the gate of FET, it consists of biocatalytic membrane, ion selective membrane, H+ sensitive membrane. They are encapsulated with the photopolymer called polyimide. Thus, it enables to separate from sensitive parts of FET. The gate material is made up of either silicon nitride, oxynitride, alumina. So any one substance the gate oxide consists of? That is, the gate oxide is made up of either materials like silicon nitride, oxynitride, alumina. These substances are deposited on the gate oxide by chemical vapor deposition method. What is chemical vapor deposition method? Which means the substance are converted into vapor and deposited on a solid substance. That is called as chemical vapor deposition. For this purpose, they use a separate heating element, furnace, carrier gas, and water-cooled copper collector. Okay, these experiment techniques will be deeply discussed in further topics. Now let us see about the working. When the test sample is placed, the analyte reacts selectively with the biocatalytic membrane. It diffuses through the ion selective membrane. The gate oxide consists of OH functionalities. When it is in contact with the solution, they are either protonated or deprotonated. The diffusion of H plus ions interfere. As a result, it brings change in polarization. Due to difference in concentration gradient of H plus ions, the solution pH will be varied. As a result, the potential difference will be changed. This will be converted into electrical signal and will be amplified as the output. It must be noted the change in potential difference is observed only when the analyte is present in the test sample. The absence of analyte in the test sample will not give positive response. From this observation, we can detect the presence of analyte in the test sample. One more ion selective field effect transistor is MOSFET, metal oxide field effect transistor. It has been schematically shown here. There is only a small difference between ISFET and MOSFET. From the picture, you can view that instead of liquid phase, you can see the presence of a metal gate. So replacement of a liquid phase with a metal gate, it forms metal oxide field effect transistor. The construction are all same, are all similar with ion selective field effect transistor, but it differ only in application. For ion selective field effect transistor, they need an external reference selector to work properly. But in the case of MOSFET, it won't need any external reference selector. And this metal oxide field effect transistor is used to sense the presence of a gas in a sample. How the gas is sensed? The metal gate identify the gas and absorb on the surface. Later, it is dissociated into atoms, individual atoms. These atoms interact partly with metal and partly with oxide interface. And due to this interaction, there will be a change in polarization. As a result, the charge distribution will vary, which brings change in voltage. Once when the voltage is varied, it gives an electrical signal. This happens only when specific gas is present in the sample. Okay, let us imagine. So you have a ternary effluent solution. Yeah, you observe an offensive smell and suspecting the presence of hydrogen sulfide gas. Which sensor you will prefer? That is MOSFET or ISFET? Yeah, we will prefer metal oxide field effect transistor because it is a field effect transistor which detect the presence of gas in a sample. Suppose if a gas sample consists of a hydrogen gas, or you want to detect the presence of hydrogen gas in a sample, you can prefer MOSFET. How the hydrogen gas is sensed? The metal oxide sensor is made up of palladium. This palladium absorbs hydrogen present in the sample, that is hydrogen gas present in the sample. After absorbing the hydrogen gas, they dissociate into hydrogen atoms. These hydrogen atoms partly interact with metal and partly on the oxide layers. The interface between the metal and oxide brings change in the polarization. As a result, it also shows a significant change in voltage. Thus, it enables us to determine the presence of hydrogen. Once when hydrogen is detected, it gives an electrical signal as an output. This metal oxide FET not only detects hydrogen gas, it also detects ammonia, amine, hydrogen sulfide, many gases. Why should we prefer this field effect transistor? Because its size is small and cheap mass produced, which is fabricated using integrated circuit technology. Our next sensor is Amperometric biosensor. Amperometric biosensor. It detects a specific element in a sample in presence of an applied voltage through measurement of current. It consists of an electrode, working electrode. When this working electrode is placed in a sample in presence of applied voltage, it detects the specific element in the sample. Electron transfer occurs, which lead to either oxidation or reduction of substrates. These electrodes consist of an enzyme called oxidase. The enzyme oxidase reacts selectively with the analyte in the test sample. It will not react with other ions. In presence of applied voltage, the enzyme reacts with analyte. As a result, electron transfer occurs between the substrate and the electrode surface. The number of electrons produced is proportional to the concentration of analyte. Thus, it enables to detect the analyte present in the sample. When the substrate reacts with enzyme, when the substrate reacts with this oxidase enzyme, it is converted into product followed with the formation of hydrogen peroxide. Later, this hydrogen peroxide is oxidized at the electrode to form H+ ions, electrons and oxygen. The sensing of an analyte depends on the consumption of oxygen, formation of hydrogen peroxide and the production of electrons. The amount of electron produced is observed in the current measurements. The number of electrons produced is proportional to the concentration of analyte present in test sample. Why amperometric sensors are more advantageous? It's all due to its low cost and disposable electrodes. The results are accurate with high reproducibility. The main advantage is it requires oxygen for enzyme activity. If the oxygen concentration is low, then the measurement is not accurate. It tends to have small dynamic range due to saturation kinetics of the enzyme. One of the example of amperometric sensor is Clark's oxygen electrode. It determines reduction of oxygen in simplest form. This Clark's electrode is used in blood glucose biosensor. It is a popular biosensor used by diabetic patient. It helps to determine the amount of glucose present in blood. Now let us see the construction and working of blood glucose biosensor. It consists of two electrodes. One electrode acts as a reference, other acts as a working electrode. Here AgAgCl is used as a reference electrode and carbon is used as a working electrode. Along with this electrode, it also consists of an enzyme called oxidase. Here we are using glucose oxidase as an enzyme. This glucose oxidase reacts selectively only with glucose molecules present in the blood. It won't react with other molecules or ions. It reacts selectively only with glucose molecules present in blood. Along with this oxidase enzyme, it also contains a mediator, that is electron transfer mediator. For this purpose, we are using ferrocene. It is a chemical substance which acts as an electron transfer mediator. These two electrodes are kept in hydrophilic mesh gauze so that the blood spread evenly. The amount of glucose sensing depends on measuring oxygen consumption, amount of hydrogen peroxide produced, electron transfer mediator. When the test sample, that is a drop of blood, is placed on the hydrophilic mesh gauze, the blood drop spread uniformly. It consists of two electrodes. The kit consists of two electrodes. One is silver chloride as reference electrode and platinum carbon as a working electrode. The platinum carbon, which act as a working electrode, involved in the chemical reaction. The enzyme glucose oxidase react selectively only with glucose molecules present in the blood. It converts the substrate into product followed with formation of hydrogen peroxide. That is, the glucose, it oxidized by glucose oxidase enzyme and convert into glucolactone followed with formation of hydrogen peroxide. This hydrogen peroxide at platinum electrode, it is oxidized to H plus ions, electrons and oxygen. The number of electrons produced can be observed from the current measurement. The number of electrons produced indicate the concentration of glucose present in the blood sample, because depending on the concentration of glucose in blood, that much amount of hydrogen peroxide will be produced. Based on the amount of hydrogen peroxide, the electrons are produced. So the release of electrons is directly proportional to the presence of glucose molecules present in the blood. Using amperometric biosensor, not only we can sense the glucose molecules or measure the glucose molecules present in blood, we can also check the freshness of a fish. So for this purpose, a biosensor is immobilized with nucleoside phosphorylase and xanthine oxidase. So these were immobilized, these enzymes were immobilized over the electrode. So the freshness of fish is assessed based on the accumulation of inosine and hypoxanthine in relation with other nucleosides. Today we have discussed about ion selective field effect transistor and metal oxide field effect transistor, which is nothing but an advanced development of ion selective electrode. It consists of two n-type, one act as a negative source, other act as a positive drain chip, and one p-type silicon chip. They are covered with 0.1 millimeter thickness of SiO2. Above this, and this constitute gate oxide of FET. Above this gate oxide FET, it consists of H plus sensitive membrane, ion selective membrane, biocatalytic membrane. It also connected with an external reference electrode to work in a proper manner. The presence of analyte in the test sample react with the biocatalyst, which bring changes in the potential difference. Thus, it enables us to determine the concentration of analyte present in the sample. Our next one is metal oxide field effect transistor. The construction are all similar, but the different application, that is, it also different construction also. Instead of liquid phase, if it consists of a metal gate oxide, it is called as metal oxide field effect transistor. It is used for gas sensing. Next sensor is amperometric sensor. So how amperometric sensor works? The presence of analyte in test sample react with an oxidase, that is an enzyme present over the electrode. In presence of applied voltage, the reaction occurs, which show a significant change in current measurement. Thus, we determine the concentration of analyte in the test sample. One of the important application is Clark's electrode. It is used in the blood glucose biosensor. We have discussed the construction and working. Using biosensor, we can also sense the freshness of fish. For this purpose, we are using a special enzymes called nucleoside phosphorylase and xanthine oxidase. The accumulation of inosine and hypoxanthine with other nucleotides helps to assess the freshness of fish. Thank you.